up the situation of trains. First, let's write the question statement. In how much time a 600-meter long train traveling at a speed 90 kilometers per hour can cross. Now there will be many things that the train is required to cross, so we'll take them one by one. First, an electric pole which is standing by the side of the track. Second, a man running at a speed 18 kilometers per hour by the side of the track. Running at a speed 18 kilometers per hour by the side of the track. That is fine. But here one important thing that will come up, what is the direction of the man? Whether he is travelling in the same direction as of the train or he is travelling in the opposite direction as of the train. Because if he is travelling in the opposite direction as of the train, it will take less time to cross him. Okay, so we will make two cases of the track. If the man is travelling in opposite direction and same direction as of the train. So this is the question, and before getting into the solution of this, I'll just explain one simple term, that is relative speed. So you write down the question completely and then come back to this, and then again we'll come back to this. Now relative speed, what is the meaning of relative speed? Let's see. Suppose Ahmedabad, Baroda, these are the two places, the distance between them is 150 kilometers. If a person starts from A at a speed 25 kilometers per hour towards B. A person starts from A at a speed 25 kilometers per hour towards B, and similarly a person starts from B towards A at a speed 5 kilometers per hour. Question is, and they start simultaneously. In how much time will they meet? Suppose this was not there, this person wasn't there. There was nobody starting from A. How much time B would take to reach A? Or the person starting from here would reach here. You can simply divide the distance by the speed. So 150 by 5, that is 30 hours. Alright. Suppose this person wasn't there. Then how much time will this person take to go from this place to this place? So distance 150 divided by speed 25, that is 6 hours. Alright. Now what is happening? Both are moving and they have started simultaneously. So what will be the effective situation? You see, in 1 hour, this person has travelled 25 kilometers. In 1 hour, this person should travel 5 kilometers. So total, how much they have travelled? Total, they have reduced the whole distance by 25 plus 5, that is 30 kilometers. Right? So effectively, they have travelled 30 kilometers in 1 hour. This 30 is called relative speed. And how did we get 30? Because we have added 25 and 5. Why did we add? Because here what is happening? Both of them are working together to reduce the distance. See, what is the meaning of meeting? Meaning of meeting is they reduce the net distance to be 0. If the distance becomes 0, they will meet. Now, to achieve the target, this person is trying, this person is also trying. So both of them are trying. So their effort will get added, right? So remember, in opposite direction, relative speed is equal to S1 plus S2. So if I call this as S1, speed first, and S2 as the speed second. So relative speed is S1 plus S2. What is the meaning of relative speed? The effective effort or the effective speed by both of them together. That is S1 plus S2. So how will you calculate time? You will calculate time as distance divided by relative speed. Hence it is 150 divided by 25 plus 5, S1 plus S2. So it is 150 by 30, which is 5 hours in this case. Obviously, this person was taking 6 hours. तो उससे तो कम ही लगेगा. So it has to be 5 hours. Alright, so this is in opposite direction. Similarly, we'll take another case of same direction, same situation, 150 kilometers. Suppose this is A, this is B. A person starts from here at a speed, let's say, in this direction at a speed 25 kilometers per hour, and in this direction at a speed from this point 5 kilometers per hour. Now when will they meet? So some of you can calculate like this. Now the same direction, so subtract 25 minus 5, that is 20. So 150 by 20, that is 7.5 hours or 7.5 hours. That is wrong, because as you can see, we talked about the effective effort. Here, what is happening? Here, this person is faster and is going away. So his effort is not contribution to the agenda of meeting. Remember, to meet, their distance should be reduced. Here, what is happening? What will happen after 1 hour? After 1 hour, this person would have gone here, traveled a distance of 25, whereas this person would have traveled only 5. So effectively, the distance between them has increased by 20 kilometers. Right? After 1 hour, this person goes 25 kilometers ahead. This person goes only 5 kilometers close. So effectively, the distance has increased by 20. So though the 20 is relative speed, I'll explain how, but the meeting is not possible. So here we'll say no meeting. Alright? Let's take another situation. Just reverse the directions. So the person from A starts in this direction at a speed 25 kilometers per hour, and the person from B in this direction at a speed 5 kilometers per hour. Now what is happening? Now the faster person is behind. So this person is traveling at 25 kilometers per hour. That means in 1 hour he will reduce the distance by 25 kilometers. But in 1 hour this person will increase this distance by 5 kilometers. So distance between them in initial situation was 150. This person has reduced it by 25. So after 1 hour it will be 125. No, this person has increased by 5. So it is effectively 130. I'll repeat. Initial distance between them is 150 kilometers. After 1 hour, this person has reduced the distance by 25, but this person has increased the distance by 5. So effectively the total distance between them has reduced by 20. So in 1 hour 20, that means the distance now is 130. After another 1 hour, the distance will be 110, further 20 reduction. So the distance will keep reducing by 20 kilometers. Here this 20 is the relative speed. Right? So directly you can memorize in same direction. In same direction, relative speed or the effective effort towards meeting, relative speed is S1 minus S2. So remember, the condition is S1 has to be more than S2. पीछे वाला fast होना चाहिए. The faster one should be behind. Then only the meeting is possible. Alright, so S1 minus S2. And that is how we get 25 minus 5, that is 20. Then calculation of time is the same process, distance divided by relative speed, which is distance divided by S1 minus S2, which is 150 divided by 25 minus 5, which is 7.5 hours. 150 by 20. Alright. So in case of relative speed, just remember, see, the word relative will come only existence only when two things are moving. Okay. So if two things are moving, then only the relative speed situation will come up. If they are moving in opposite direction, then the speed will get added. The speeds will get added. And the time calculated would be distance divided by relative speed, that added speed. If they are moving in same direction, then first check whether the meeting is possible or not. The meeting will be possible only when the faster one is behind the slower one. Alright. Then in that case, the distance traveled, the distance between them divided by relative speed will be S1 minus S2. Okay. Now, once we have done this, now come to this situation. In how much time a 600 meter long train is traveling at a speed 90 kilometers per hour, can cross an electric pole and can cross a man running at a speed 18 kilometers per hour? Okay. Now here, the distance or the length is 600 meters. So let's do one thing. First, convert the speed of train. Let's call S is the speed of train. So 90 SP. Is the speed of, or let's say S, just S, is the speed of train. So speed of train is 90 kilometers per hour. I'm sure you can memorize or you can recall it is 90 kilometers per hour. So 90 into 5 by 18. So 25 meter per second. Speed of man, as and when necessary, let's call it SM, that is 18 kilometers per hour. Hence it is 5 meter per second. But for that electric pole, we don't require anything. Okay, first let's do the question of electric pole. What is the meaning of the situation? Look at this very carefully. Suppose this is the pole. The pole doesn't move, right? The train comes. First, let's try to understand what is the meaning of the question. What do they want to know? What they want to know is find the time taken by the train. This is the train to cross this pole. Now see, the pole doesn't move. When will you count, or how will you count the time for the train to cross the pole? Okay, look at this. So train is coming, train is coming, train is coming. When the train reaches in this position where the head of the train or the engine of the train is just touching the electric pole or just by the side of the electric pole, at that time you start your counting. So I'll say start the counting, let the train pass through, and when the end of the train passes electric pole, at that moment you stop your counting. So from this position to this position. Alright, so the position of beginning of the train by the side of electric pole, then train moves ahead, pole stays at its own point. Okay, I'll repeat, pole stays at this point, train comes. When the train's head position, head point or first point touches the electric pole, you start counting. When the train's last point touches the electric pole, stop counting. So the duration in this situation, the duration in this process is the time taken by the train to cross the pole. Now see, what is the distance traveled by the train? The distance traveled by the train is its own length, right? From this position to this position. So it has traveled its own length. So remember, whenever a train has to cross a simple point, it covers its own length. That's it. So let's take the situation first. Electric pole. Let me draw a pole. This is the pole. Let's say this is the pole which is fixed. Now this is the train. Let's make it a funny train, a bullet train. Now the length of the train is 600 meters. The speed is 25 meters per second. We have already discussed that to cross a pole, it just needs to cover its own length. It has to start from here, when this nose is here up to this situation. Alright, so this is the train. I'll draw another situation wherein I can show that this from this position to this position, right? The time taken in going from this to this position is the time taken by train to cross the pole. So it has traveled its own length. So the time taken will be equal to length of train divided by speed of train. So it is equal to 600 by 25, which is 24 seconds. So 600 meters divided by 25 meters per second. So it is 24 seconds. So the train will cross an electric pole in just 24 seconds. So remember that. To cross an electric pole, the train needs to travel its own length. So the time taken will be its own length divided by its own speed. Now in the second case. Now what is the meaning of second case? The meaning of second case is like the pole has started moving. I mean, there is no pole. Instead of pole, now there is a man. Right? So now what will be the situation? Let's see. This is the train. Alright. This is 600 meters. Speed is 25 meters per second. And there is a man. Okay. A smiling man. Now the first case. If he is moving in opposite direction. So the train is going in this direction. The man is coming in this direction. Speed of the train is 25 meters per second. Speed of the man is 5 meters per second. Now you see, both of them are contributing towards crossing. In this situation, the pole was not doing anything. Entire work was done by the train. Here, the man is also helping the train to cross. So effectively, what we have to consider is relative speed. So in this case, the time taken will be equal to. Now see, the distance traveled will still be the same. It is just that this was the pole. Train came here. We started counting. We stopped counting. Now in this case, pole is also moving. Look at my hand. Initially, for case of pole, my left hand was not moving. Only the right hand, that was the train, was moving. But in case of man, my left hand is also moving, right hand is also moving. So now the time taken will reduce. Okay. So the time taken will be, why will it reduce? Because they are moving in opposite direction, so the speed will get added. So the time taken will be equal to, but the distance traveled is still the same, right? Only the length of the train divide by speed of, so this is the first part, speed of train plus speed of man. This is opposite direction. So it is 600 divided by 25 plus 5, which is 600 by 30, which is 20 seconds. Then in case of same direction, what will happen in case of same direction? If the man is moving in this direction, now what is happening? This is for A and this is for B. If the man is moving in this, and now you see, the train is behind the man. Now the man is not contributing, he is actually opposing the crossing process. Okay? So in this case, the effective speed will reduce. Okay? So in this case, time taken will be equal to length of the train, but the distance traveled is still the same. Opposite relative speed will change. So speed of train minus speed of man. So this will become 600 divided by 25 minus 5, which is 600 divided by 20, which is 30 seconds. So remember, so when the man and train are moving in opposite direction, the speeds will get added. So time taken will be length of the train divided by added speeds. Added speed. If the train and the man are moving in same direction, then the effective speed will reduce. The effective effort will reduce. So we have to take the difference of speeds as the relative speed. To find the time, divide the length of the train. The distance traveled is still the same, only the length of the train, divide by the relative speed. Alright? Now, so this information will remain same in how much time a 600 meter long train traveling at a speed 90 kilometers per hour can cross a 300 meter long platform. Alright? And a 300 meter long train running at a speed 54 kilometers per hour in the direction opposite, and second case same as the first train. Question number 3 we take first. In question 3, what do we have to consider? This is the train and this is the platform. Let's say this is 600 meters. It is traveling in this direction at a speed, let's say 25 meters per second, or it's given already. And this is 300 meters. First we need to decide what is this platform is stationary, it doesn't move. Okay, it is fixed. Obviously platforms don't move. Okay. Suppose this is my platform. I kept it in my left hand. Platform is fixed. How do you start counting? So when the train is coming, when the train's head touch the first point of the platform, we start counting. Now it could be a platform, it could be a bridge, it could be a stationary train, right? The same thing in all cases. So we'll start counting like this when this head approaches at this position. So start counting, then continue, 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 and then stop counting. So when the train has gone from this position to this position, we'll stop our counting. So start counting from this position, let the train cross, let the train reach this position and stop your counting. See, the platform hasn't moved. Only train has done the entire work. So the speed will be considered only of this train. But the distance traveled, now you see, distance traveled by the train or distance traveled overall is this, its own length. First its bridge length, then its own length, or you can say its own length and then the bridge length or the platform length. So what is the total distance traveled? The length of the train plus length of the bridge, yeah, platform, yeah, other train. Okay. So in any case, the total distance traveled is the sum of lengths. Lengths of this train and this platform. Alright. So the total distance traveled in this case will be 600 plus 300. So what do we say? We say the time taken is equal to, what do we have to do? Distance by time. So in place of distance, we will have length of the train plus length of the platform or the bridge, whatever is there. Divide by speed. Platform is not doing anything. Everything is done by the train. So speed of the train. So it is 600 plus 300. Divide by 25, which is equal to 900 by 25, which is 36 seconds. Be careful about the units. We have already taken care of the units initially. Okay. Now the fourth case. Now fourth case, what is happening? The first train that we had was already moving at a speed 25 meter per second. Its length is 600 meters. Now there is another train. Let's say that it is moving in opposite direction, the first case. Its length is 300 meters and it is moving in this direction at a speed 54 kilometers per hour. Oh, so 54 kilometers per hour we have to convert into meter per second. How much will it be? This will become 18 3s are 54. So 5 3s are 15 meter per second. Remember, now we have to consider 15 meter per second. Okay. Now they're moving in opposite directions. If you describe the same situation again, so my left hand had held a platform earlier. This was the train moving. Now what is happening? Both of them will move. So both my hands are moving now. So if both are moving still, the distance traveled will remain same. That is the sum. But if they are moving in opposite direction, that means both of them are putting the effort. Hence their speeds will get added. Right? So that is relative speed. So we have to consider relative speed in this case. So A, which was the case of opposite direction. So this was the case of opposite direction. In case of opposite direction, speeds get added. So time taken will be equal to length of first train plus length of second train. L1 plus L2 divide by opposite direction ke liye S1 plus S2. So it is 600 plus 300 divided by 25 plus 15. Be careful about the units. So it is 900 divided by 40. This is 90 by 4, which is 22.5 seconds. This is the time taken by them to cross each other. Whereas in case of same direction, this was for opposite direction. For same direction, what will happen? See, for opposite direction, this was the train, this was the train. So they crossed each other. Whereas in same direction, suppose this is the slower one, this is moving, the faster one is coming from behind and is crossing. See, again. So counting starts, counting stops. So in this case, it is going away, right, in the same direction. That means it is not helping, it is rather, reducing the effort. So here again, we will apply that concept of subtraction. So in that case, what will be the time? Time taken will be equal to, length is the same, L1 plus L2, because that is still added, right? Speeds way, it will be S1 minus S2. So we have 600 plus 300 divided by 25 minus 15, which is equal to 900 by 10, which is 90 seconds. I simply like to write certain cases. Train, pole. Remember, first case, time taken is equal to length of the train divided by speed of the train. So train to cross pole. Second, train, man. Now if the man is stationary, then it has to be same as the pole. But if it is man moving, then two cases. Time in opposite direction is equal to length of the train divided by speed of the train plus speed of the man. Time in same direction is equal to length of the train divided by speed of the train minus speed of the man. Third case, train, platform or bridge or anything that has a length but it is stationary. Okay. In this case, what will happen? Time taken is straight away. There is no question of opposite or same direction because platform and bridge are stationary. So length of the train plus length of the platform or length of the bridge. Alright. Divide by S of the train, that is speed of the train. And the final case, two trains. Now, two trains would mean two lengths L1, L2 and two speeds S1 and S2. Then their crossing time, if they are moving in opposite direction, is straight away equal to L1 plus L2. The distances are always added wherever necessary. But in opposite direction, the speeds will get added. And in same direction, the time to cross each other will be length still the same, L1 plus L2, but speeds will be S1 minus S2. Make sure that the question has to be answered as faster train crossing the slower train. So this is the summary of this whole thing. Okay, now in this session, we will take a couple of questions, then we will take average speed and riverboat. Okay, so first question. A train crosses a pole in 24 seconds and a 300-meter long bridge in 39 seconds. Find length and speed of train. Alright. So if you follow the methods or the formulas that we had discussed in the last session, we can directly take it as first case train pole, so length of the train divided by speed of the train, that is equal to 24. And second case, length of the train plus length of the bridge divided by speed of the train, that is equal to 39 seconds. So we have two equations and two variables. We can calculate them very easily. Alright, what you can do is, from here you will get L is equal to 24S. You put it in this second equation, you will get 24S plus 300 is equal to 39S. This S goes to the other side. Send 24S on the other side, you will get 300 is equal to 39 minus 24, that is 15S. So S is equal to 300 by 15, which is 20 meter per second. So speed of the train is 20 meter per second. You can convert it into kilometers per hour, which is equal to 20 into, we have to convert in kilometers per hour. So it will become 18 by 5 kilometers per hour. So 5 4s are 4 into 18, which is 72 kilometers per hour. Alright. So this is speed of the train. To find length of the train, you have already found the value of S in meter per second here. Put it here. So you get length of the train as 24 into 20 meter per second. So 24 seconds into meter per second. That will give us 24 into 20, that is 480 meters. So length of the train is 480 meters and the speed of the train is 72 kilometers per hour or 20 meters per second. Be careful, don't put 72 here in place of S, right? Because this 24 was in seconds. So the value of S will be 20. This can be done directly also. You see, what is the distance traveled by train to cross a pole? Its own length. What is the distance traveled by the train to cross a bridge? Its own length plus extra 300. Right? So, for pole, which is own length, it is taking 24 seconds. For bridge, which is L plus 300, it is taking 39 seconds. For this extra 300 meters, it is taking extra 15 seconds. Right? So in 15 seconds, the train is traveling 300 meters. So that means in 1 second, it will travel 300 by 15, which is 20 meters. So that is the speed, 20 meters per second. So this can be done directly also, without writing the formulas. Now once I get speed as 20 meters per second, its own length in 24 seconds, so length of the train can be calculated as 20 into 24, which is 480 meters. So this is the other way of doing this. A thief starts running from a policeman's house at 5 a.m. at a speed 60 kilometers per hour. The policeman realizes that something has happened or some theft has happened at, let's say, 8 a.m. So he starts chasing, right? Suppose he is aware about the direction of the thief or in which direction the thief has gone. Okay. So the policeman starts chasing the thief at a speed 80 kilometers per hour at 8 a.m. So the policeman starts at 8 a.m. The thief has already started at 5 a.m. The question is, at what time and at what distance the policeman catches the thief? what time and at what distance the policeman catches the thief. Now look at the situation at 5 a.m. What is the situation at 5 a.m.? This is the house of policeman and the thief starts running from here at a speed 60 kilometers per hour. And what is the situation at 8 a.m.? This is still the house of policeman, but the thief has already travelled 3 hours, 5 a.m. to 8 a.m. So in 3 hours, thief would be here, policeman would be here, and how much will be this distance? Whatever is the distance travelled by thief in 3 hours at a speed 60 kilometers per hour, so this distance has to be 180 kilometers. So this becomes a situation of relative speed. The thief is running at a speed 60 kilometers per hour. Policeman is running at a speed 80 kilometers per hour. Because it says the policeman has started chasing. Chasing, that means he is running in the same direction. So right now it's a question of relative speed. So the time taken will be equal to the distance 180 divided by. Now they're running in same direction. Will the meeting be possible? Yes, because the faster one is behind. So 180 divided by relative speed, that is same direction ke liye we have to subtract. So it is 80 minus 60. So it is 180 divided by 20. So time is equal to 9 hours. That means the thief will be caught after 9 hours. After 9 hours? 9 hours from what? 5 a.m. or 8 a.m.? See, the policeman has started chasing at 8 a.m. After that he has taken 9 hours. So the time or the moment will be 8 a.m. plus 9 hours. That will become 8 a.m. plus 9 hours. That will become 17, that is 5 p.m. So thief will be caught at 5 p.m. Alright. Now the second part of the question is, at what distance from the policeman's house the thief will be caught? The policeman has started at 8 a.m. He has travelled for 9 hours. The speed of policeman is 80 kilometers per hour. So the distance is 80 into 9, which is 720 kilometers. Right? Policeman has travelled for 9 hours and at a speed of 80. Whatever distance he has travelled to catch the thief only. So the total distance will be 80 into 9, which is 720 kilometers. You can calculate with the help of the speed of thief as well. The only thing is, thief has started at 5 a.m. So the total time for which the thief has run is 5 a.m. to 5 p.m., which is 12 hours. So if you multiply 12 hours into 60 km per hour, you will get the same distance. Obviously, right? Both of them, the total distance traveled by both of them has to be the same. So the distance is 720 kilometers. Time is the moment is 5 p.m. Duration is 9 hours. A 500 meter long train crosses a man sitting in a 300 meter long slower train in 45 seconds. The speed of slower train is 72 kilometers per hour. Find the speed of faster train. Read the question carefully. A 500 meter long train crosses a man sitting in a 300 meter long slower train in 45 seconds. The speed of slower train is 72 kilometers per hour. Find the speed of the faster train. Here we do not have to consider the crossing of two trains. Right? Please read the question very carefully. It says the long train, the longer train or the faster train, this is the faster train, crosses a man sitting in a 300 meter long train. Now understand, if a man is sitting in the train, then his speed would be same as that of the train. Okay. Now here one more thing is required, that the speed of the train is 72 kilometers per hour in same direction. In same direction. So both the trains are in same direction. Okay. In same direction. Now find the speed of the fast train. So now what is the situation that we need to understand? There is a train. Let's say this is the faster one. The length of this train is 500 meters. Speed is unknown. Let's say it is S. Okay. Then there is slower train. The length of this is 300 meters. Alright. And there is a man sitting in this train. Now here, this length doesn't matter. This train also doesn't matter. We only have to consider the man. The speed of the man is 72 kilometers per hour. And for that matter, it is 20 meters per second. So basically, the man is moving at a speed 20 meters per second and this train has to cross this man. So this is the situation of train and man, not of two trains. Right? So the time taken will be equal to only the length of this train divided by speed of the train plus speed of the man. It is in the same direction, so it is S minus speed of the man. Okay. Just understand this again. The man is sitting in the train. The significance of that is the speed of the man will be same as the speed of the slow train. That's the only requirement of the second train. So this 300 meter is not required at all. Only the speed is required. Right? So this train crosses this man. Whether he's sitting in the train or is traveling on his own is the same thing in this situation. Okay. Now time is given 45. Length is given 500. Speed of the train we have to find. Speed of the man is 20. Alright. So we get S minus 20 is equal to 500 by 45. This will become 100 by 9. Let it be for some time. So S is equal to 100 by 9 plus 20, which is 180 plus 100, 280 by 9 meter per second. So this is the speed of the train. This is 280 by 9 meter per second. Okay. Suppose we have to find in kilometers per hour. So it will become 280 by 9 into this. We are converting from meter per second to kilometers per hour. So multiply by 18 by 5. So 9 2s are and 5 56 times. So it becomes 112 kilometers per hour. The question of average speed will arise only if there are certain distances which are travelled at different speeds. See, if you travel a distance at constant speed, the average speed of the entire duration will remain same as the constant speed, right? But suppose if the distances are travelled in parts, or a given distance is travelled in parts, and the speed in every part is different, or is changing, then only the situation of average speed will arise. Okay. We already know that distance is equal to speed into time. So we know that speed is equal to distance by time. Alright. So the first thing that we need to understand, for all cases, average speed is equal to the total distance travelled divided by total time consumed. Okay. Now let's take some situations. In the first case, let's say if a person travels 800 kilometers in 5 hours, and then so additional 500 kilometers in 15 hours. This is the simplest situation. I'll write the heading as find average speed. Okay. So what will be the average speed in this case? We just follow this expression, total distance by total time. So speed average is equal to total distance is 800 plus 500 divided by 5 plus 15, as simple as that. Units should be same. So 5 hours and 15 hours are in hours, kilometers, 500 and 800 kilometers. So 1300 kilometers divided by 20 hours. So 130 by 2, which is 65 kilometers per hour. Please try to understand that 65 kilometers per hour is the average speed. The person may not have travelled at actually at this speed. Right? This is the final average speed. Let's check the speeds in the cases, first parts. In the first part, the speed is 800 by 5, which is 160 kilometers per hour. See, the speed in the first part is 160 kilometers per hour. Speed in the second part is 500 by 15. So it is 100 by 3. That is 33 1 by 3 kilometers per hour. So the speeds in the parts are nowhere related to this. Also, you can see that this value is not the simple average of these two values. Right? So be very careful. It is total distance by total time. That is how we calculate the average speed. Okay. Yeah. Now one more thing. Suppose these times are same. Suppose these. Okay. So I'll just write the. In this case, what are the things given? Speed, distances are given and the times are given. So I'll write the generalized expression. S average in this case is equal to D1 plus D2 plus D3 and so on. If there are more parts, divide by T1 plus T2 and so on. Let's take the second case. Now in this case, there were different parts. The distances were traveled in different parts. Distances were given and the times were given. Let's change the situation. Suppose speed and time was given. A person travels at a speed 60 kilometers per hour for 25 hours and then at a speed 90 kilometers per hour for 5 hours. Find average speed. Alright. Now in this case, distances are not given, so we have to calculate the distances first. Right? We know the distance is equal to speed into time. So the first part, distance D1 is equal to S1 into T1. The second part D2 is equal to S2 into D2. S2 into T2. So either you calculate here or you directly write S average is equal to D1 plus D2 by T1 plus T2. Right? Now in place of D1 and D2, you can write these expressions. So S average will be equal to S1 into T1 plus S2 into T2 divided by T1 plus T2. Alright? Then we calculate. So S1 into T1, that is 60 into 25. This is the first speed, this is the first time, this is the second speed, this is the second time. 60 into 25 plus 90 into 5 divided by 25 plus 5. Okay, simplify this. So if you solve this, you will get average speed as 60 into 25 will be 1500 plus 90 to 5, that is 450 divided by 30. So it is 1950 by 30. So cancel it. 3 will cancel it, 65 kilometers per hour. So whatever is the value that you get. Now it's a coincidence that we have got 65 here and 65 here. Just a coincidence. Right? If you see, the simple average of 60 and 90 would have been 75. Here it is 65. So it is this, again I am saying that this value, average speed, is not the average of the speeds. It is the average speed. Just one phrase. Average speed is one phrase. It is not the average of the speeds. Okay. So you don't do S1 plus S2 by 2. Though you can do S1 plus S2 by 2 in one case. So sub case of this situation, if times are same, then what will happen? If times are same, that means let T1 equal to T2 equal to T. Then this average speed from here, this will become the generalized expression for this. Average speed will become equal to S1 into T plus S2 into T divided by T plus T. So T common and each will have 2T. So it is T common, S1 plus S2, and we will have 2T. So TT gets cancelled and we get S1 plus S2 by 2. Oh, so that means if the times are same, then average speed is equal to average of the speed. Not always. So this is special case. Special case. If the distances are travelled in different parts, the speeds are given in different parts and the times are different, then we apply this expression to find the average speed. and if the times are same, then we take simple average of the speed. This is the only case where the average speed is equal to average of the speeds, when the times are same. Now, in the first case, we had taken distance and time. In the second case, the speeds and the times of different parts were given. Now, third case in which, what is remaining? What combination is remaining? Distance and speed combination is remaining. So, third case, a person travels, let's say 600 kilometers at a speed 30 kilometers per hour, right? And 900 kilometers at a speed 90 kilometers per hour. So here distance and speeds are given, and again यहाँ पे I put and then, so the separate parts are there. Find speed average. Now here times are missing. Alright. So first we need to calculate the time. So first part time will be first distance by first speed. Second part time will be first distance, second distance by second speed. And if there are more parts, we can continue doing this. So either we calculate here or we put the expression like speed average, that is equal to d1 plus d2 upon d1 plus d2. That is our original expression. And then in this case, speed average will become, we know d1, we know d2, but in place of t1, we'll take d1 upon s1. In place of t2, we'll take d2 upon s2. Alright, and then we put the values. So d1 plus d2 will be equal to 600 plus 900 divided by 600 plus 600 by 30 plus 900 by 90. So these are the times. So we have 1500 divided by 600 by 30 is 20, 900 by 90 is 10. So 1500 by 30. So it is 50 kilometers per hour. In this case also there will be a special case. So from here, special case. What will be the special case? If distances are same, that means let d1 equal to d2 equal to d, then this average speed will become d plus d divided by d by s1 plus d by s2. So from here d will come out. So in numerator we have 2d and in denominator we have d into 1 by s1 plus 1 by s2. So d gets cancelled out and we will have s average equal to 2 upon 1 upon s1 plus 1 upon s2. And you simplify to get 2 s1 s2 upon s1 plus s2. So the average speed will be calculated as 2 into product of speeds divided by sum of speeds. But this is which case? If the distances travelled are same. Alright, so remember, if the distances travelled in two parts are same, then the average speed is calculated as 2 into product of speed divided by sum of speeds. This value is also known as harmonic mean. Right now you just write it down. Okay, it is called harmonic mean of S1 and S2. Harmonic mean, that is HM. HM of S1 and S2. In concepts of series, we will learn this. Harmonic mean is 2 into product of numbers divided by sum of numbers. The way it is, this is called arithmetic mean. This S1 plus S2 by 2 is called arithmetic mean. Arithmetic mean of S1 and S2. In short, it is called AM. So arithmetic mean in case of same time and harmonic mean in case of same distance. So here we would not require the value of distances. We can directly calculate from the speeds. Now just understand one more thing. If there are two parts, then this is the expression that has to be there. If there are three parts, then it will not be 2s1, s2, s3 upon s1 plus s2 plus s3. It will be from here 3 upon 1 upon s1 plus 1 upon s2 plus 1 upon s3. If there are four parts, then it will be 4 upon 1 upon s1 plus 1 upon s2 plus 1 upon s3 plus 1 upon s4. So वहां से आपको solve करना होगा. So I'll just continue with the question number 3, but I'll put, let's say 1 here and 3, 2 here. A person goes from A to B at a speed 40 kilometers per hour and comes back. So comes back automatically means from B to A by default. Comes back at a speed 60 kilometers per hour. Find average speed for his entire journey. Now please understand that in this case, entire journey would mean going from A to B and then coming back. That means same distances are travelled at different speeds. Speeds are 40 and 60. So straight away we will apply this expression to find average speed as 2 into 40 into 60 divided by 40 plus 60. The formula is 2s1 upon s1 plus s2. Right? As average for same distances. And remember, only for 2 parts. You will not be asked anything more than 2 parts. It is 2s1 s2 upon s1 plus s2. So 2 into product of speeds divided by sum of speeds. So this will become 2 into 40 into 60 divided by 100. 0, 0, 2 into 4 into 6, that is 48 kilometers per hour. Remember, distances are same, times are not. Right? Obviously, if the distances are same, speeds are different, the times would be different. Okay. So it is again not the simple average of 40 and 60, it is something else. There is another way of asking the same thing. A person travels half the distance at a speed 60 kilometers per hour and the remaining half at a speed 90 kilometers per hour. Find his average speed. Average speed for the entire journey. See, the person has travelled half the distance at a certain speed. So the distances are same. Right? Whatever is the value of the distance, that doesn't matter. Half the distance, half the distance. So same distances. So speeds, in this part speed is S1, in this part speed is S2. So we'll still apply the same formula. 2 into S1 is 2 upon S1 plus S2. So we'll have average speed is equal to 2 into 60 into 90 divided by 60 plus 90. So we'll have 2 into 60 into 90 divided by 150. Right? So I think this will be cancelled. 3 5 times and 3 3 times and then 5 12 times. So 12 into 36 to 72 kilometers per hour. Mostly the questions of average speed will be asked like this only. Find the average speed. That would be the general statement. Okay. Now, a different question altogether, but though it will look like an average question of averages, average speed. A person travels total 1000 kilometers in 20 hours in 2 parts. First part in a train at a speed 80 kilometers per hour. The train speed is 80 kilometers per hour. And the second part in a bus at a speed 40 kilometers per hour. Question is, find the distances travelled. Distances travelled in the 2 parts. See, if the question asks what is the average speed, then answer will be simply 1000 by 20, that is 50 kilometers per hour. But that is not the question. Alright, question is something else. Find the distances travelled in the 2 parts. Suppose the person travels x kilometers in the train and y kilometers in the bus. Then the one equation that we'll have is x plus y equal to 1000. Now speed of the train is 80 kilometers per hour. So the time taken for this x kilometers will be x by 80. Speed of the bus is 40 kilometers per hour. Then the time taken for this distance y will be y upon 40. Time is distance divided by speed. And the total time is equal to 20. So these are the two equations which we need to solve together to get the values of x and y. Now from the second one, if you multiply by 80 in the whole equation, we get x plus 2y equal to 1600. And one equation we have x plus y is equal to 1000. Simply subtract. So you see x gets cancelled. 2y minus y is y. And 1600 minus 1000, that is 600. So y is 600 kilometers. So automatically x is 400 kilometers. Basically you solve these two equations. So this is one way of doing this question. Then you can obviously you can find the times taken. So in the train, the person travels 400 kilometers, and the time taken would be 400 by 80. That is 5 hours. So obviously in the bus he should spend remaining 15 hours. Bus, you can calculate separately also. 600 kilometers, the time taken will be 600 by 40, which is 15 hours. You can confirm the total time is 15 plus 5, which is 20 hours. So this is one way of doing this. Similarly, you can assume the times and you can calculate. Similarly, instead of y, you could have taken 1000 minus x as well. Right? So whatever way you want to do, this is the fundamental method. Then you can make necessary changes according to your understanding. Right? So though it looks like an average question, but it is not a question of average speed. Okay, it is a rather simple question of equations. If you assume the times to be t1 and t2, the other method. Suppose we take t1 time in train and t2 time in bus. Then the equation will be t1 plus t2 equal to 20. Then the distances traveled in the train. Now the time taken is t1, speed is 80. So 80 into t1. Now speed of the bus is 40. So 40 into t2. These are the distances traveled in train and the bus. They should be equal to 1000. Similarly, if you solve these two, you will get, you can multiply the first equation by, let's say 40. And you can solve. So 40 t1 plus 40 t2 is equal to 40 into 20, that is 800. Second equation is 80 t1 plus 40 t2 is equal to 1000. So subtract this equation from this equation, you get 80 minus 40, that is 40 t1 equal to 1000 minus 800, that is 200. So t1 is equal to 5 hours. And hence t2 is equal to 20 hours. And then further you can calculate the distances. So this was the other method.